Hello, and welcome to an episode that talks about water management. I'm Swati Singh, a media professional for the last 12 years specialized in mass communication. I have worked as a media professional with the Hindustan Times, the Indian Express, Career Launches, the Times of India, etc. And I've also taught media and development in various universities and colleges, including the Delhi University. Today, we shall be discussing about water management. We will try to understand the meaning, need, and significance of saving water resources. Development is a constant and continuous process, but it causes massive devastation, especially with respect to the depletion of various natural resources, including the water. Water is one of the most important elements of our survival. It is inherent to understand that when we conserve a precious resource like water, we are improving the economic, environmental, and social components as well. First, let's start by discussing the objectives of this episode. The objectives of this lesson are to learn about the importance of water, to learn about the resources for water scarcity, to understand the methods of water conservation, to learn about the various indicators of development, to understand the benefits of water conservation. Let's start with the introduction. With growing population and problem of global warming, it has become all the more important to focus on conserving water and environment. Two of the most significant factors that we have to keep in mind while working on these issues is the issue of water management and waste management. Today we shall be discussing about the importance of water management, and in the process we learn about how to manage these effectively. Let us understand the phenomena of water management by asking, what is water management? Well, it is the activity of movement and control of water resources to minimize the damage to property and life, and also to maximize the efficient beneficial use known as water management. If the management of water is good in dams and leaves, it reduces the risk of harm caused due to flooding. Water management is a process of developing, optimizing, and planning of water resources via many practices which are defined by many policies and regulations. With the increase in the population, which has been doubled to over 6 billion people from 1900s, the use of water has popped up to 600%. According to the statistics, the health of people is threatened by inadequate access to clean water for drinking and sanitation. We now further move to the concept of water scarcity. Water scarcity is being driven by two converging phenomena. The first is the growing freshwater use, and the second is the depletion of the usable freshwater resources. Water use has been growing globally at more than twice the rate of the population increase in the last century, and an increasing number of regions are reaching the limit at which water services can be sustainably delivered, especially in arid regions. Water scarcity will be exhausted as rapidly growing urban areas place heavy pressure on neighboring water resources. At the global level, 31 countries are already short of water, and by 2025, there will be 48 countries facing serious water shortages. The United Nations has estimated that by the year 2050, 4 billion people will be seriously affected by water shortages. This will lead to multiple conflicts between countries over the sharing of water. Around 20 major cities in India face chronic or interrupted water shortages. There are 100 countries that share the waters of 13 large rivers and lakes. International accord that will look at a fair distribution of water in such areas will become critical to world peace. India and Bangladesh already have a negotiated agreement on the water use of the Ganges. We can also need to talk about water pollution. We also need to talk about water pollution. Let us understand the causes of much of the pollution in rural areas are untreated sewage, resulting from a lack of toilets and sewers, salts, fertilizers and pesticides from irrigated land contaminates the flowing water and groundwater supplies, as well as the salt water entering overused aquifers. Places with sewers often have no wastewater treatment facilities, while the sewage becomes dumped right into the water supplies, a source which people draw from. Agriculture-related pollution such as fertilizer, pesticides, animal waste, herbicides, salts from evaporated irrigation water and silt from the deforestation washes into the streams, rivers, lakes, ponds and the sea. This agriculture runoff sometimes severes, creating dead zones in coastal water zones. Industry-related water pollution comes from toxic chemicals and heavy metals from mining and manufacturing. Power plant emissions that create acid rain that contaminates the surface water. People often bathe, wash their clothes and swim in disgusting water. They also drink water from uncertain quality coming from ponds and streams used by the animals. The water and air around the cities are polluted, and the water shortages and quality in rural areas are still rampant. Therefore, we need to do water management. Now, one may ask what water management is and what are the techniques of managing water. So, water management therefore is the need of time. It is the management of water resources for the coming generations. It involves the activity of planning, developing, distributing and managing the optimum use of water resources. We would discuss the different methods through which water management preservation can be done. Some of them are explained here. Let's start with the rainwater harvesting. One of the most popular techniques is rainwater harvesting, which is the collection and storage of the rainwater rather than allowing it to run off. Rainwater is collected from a roof-like surface and redirected to a tank, cistern, deep pit, well shaft or borehole, aquifer or a reservoir with percolation. Dew and fog can also be collected with nets or other such tools. Rainwater harvesting differs from stormwater harvesting, as the runoff is collected from roofs rather than creeks, drains, roads or any other land surfaces. Its uses include watering gardens, livestock irrigation, domestic use with proper treatment and domestic heating. The harvested water can also be committed to long-term shortage or groundwater recharge. As an example, we talk about Tamil Nadu, which was the first state to make rainwater harvesting compulsory for every building to avoid groundwater depletion. The scheme was launched in 2001 and has been implemented in all rural areas of Tamil Nadu henceforth. Posters all over Tamil Nadu, including rural areas, create awareness about harvesting the rainwater. It gave excellent results within 5 years, and slowly every state took it as a role model. Since its implementation, Chennai has a 50% rise in water levels in 5 years, and the water quality significantly improved. In Rajasthan, where there is utmost dearth of water, rainwater harvesting has traditionally been practiced, especially by the people of Thar Desert. Many ancient water harvesting systems in Rajasthan have now been revived. And another very powerful technique is groundwater recharge. Groundwater recharge is the enhancement of the natural groundwater supplies using man-made conveniences such as infiltration, basins, trenches, dams, or injection wells. Aquifer storage and recovery is a specific type of groundwater recharge practiced with the purpose of both augmenting groundwater resources and recovering the water in the future for various uses. Groundwater is recharged naturally by rain and snow melt, and to a small extent by surface waters. Recharge may be impeded somewhat by human activities, including paving, development, or logging. These activities can result in the loss of topsoil, resulting in reduced water infiltration, enhanced surface runoff, and reduction in the recharge. The use of groundwater, especially for irrigation, may also lower the water tables. Groundwater after recharge is an important process for sustainable groundwater management, since the volume rate abstracted from an aquifer in the long term should be less than or equal to the volume rate that is recharged. Recharge can help move excess salts that accumulate in the root zone to deeper soil layers or into the groundwater system. These roots increase water saturation into groundwater after reducing water runoff. Flooding temporarily increases riverbed permeability by moving the clay soil downstream, and this increases aquifer recharge. A simple and useful technique of water conservation is artificial groundwater recharge. Since groundwater levels are declining across the country as our withdrawals exceed the rate of aquifers to naturally replenish themselves, called recharge. One method of controlling declining water levels is by using artificial groundwater recharge. Artificial recharge is the practice of increasing the amount of water that enters an aquifer through human-controlled means. For example, groundwater can be artificially recharged by redirecting water across the land surface through canals, infiltration basins, or ponds, adding irrigation furrows or sprinkler systems, or simply injecting water directly into the subsurface through injection wells. Artificial groundwater recharge is becoming increasingly important in India, where the overpumping of the groundwater by farmers has led to the underground resources becoming depleted. In 2007, on the recommendation of the International Water Management Institute, the Indian government associated 1,800 crores to fund dug well recharge projects. A dug well is a wide, shallow well, often lined with concrete, in 100 districts within 7 states where water stored in hard rock aquifers has been overexploited. Another environmental issue is the disposal of the waste through water. Flux such as dairy farms, industrial and urban runoffs. A new and useful method of saving water is the drip irrigation. Drip irrigation is a type of a micro-irrigation system that has the potential to save water and nutrients by allowing water to drip slowly to the roots of the plant, either from above the soil surface or buried below the surface. The goal is to place water directly into the root zone and minimize evaporation. Drip irrigation systems distribute water through a network of valves, pipes, tubing, and emitters. Depending on how well designed, installed, maintained, and operated it is, a drip irrigation system can be more efficient than other types of irrigation systems, such as surface irrigation or sprinkler irrigation. In the drip irrigation process, water and nutrients are delivered across the field in pipes called dripper lines, featuring smaller units known as drippers. Each dripper emits drops containing water and fertilizer, resulting in the uniform application of water and nutrients directly to each plant's root zone across an entire field. Drip irrigation system delivers water to the crop using a network of main lines, sub-mains, and lateral lines with emission points spaced along with their lengths. Each dripper emitters orifice supplies a measured, precisely controlled uniform application of water, nutrients, and other required growth substances directly into the root zone of the plant. Another very unconventional way of saving water is by a technique called grey water. Grey water is gently used water from your bathroom sinks, showers, tubs, and washing machines. It is not water that has come into contact with feces, either from the toilet or from washing diapers. Grey water may contain traces of dirt, food, grease, hair, and certain household cleaning products. While grey water may look dirty, it is a safe and even beneficial source of irrigation water in a yard. Grey water is water from basins, baths, and showers that is piped to a surge tank. The grey water is held briefly in the tank before being discharged to an irrigation or a treatment system. The grey water can be diverted either by gravity or by using a pump. The surge tank can be a type of container that is suitable for holding but not storing the initial surge of the water. The surge tank must be emptied completely each time grey water is dispersed to the irrigation or treatment system. Grey water must not sit for extended periods of time in the tank. A gravity system can only be used when there is sufficient fall from the laundry, bathroom drain to the storage tank. An old but very useful technique is the sewage water treatment. Sewage treatment is the process of removing contaminants from the municipal water waste, containing mainly household sewage plus some industrial wastewater. Physical, chemical, and biological processes are used to remove contaminants and produce treated wastewater or treated effluent, and that is safe enough for release into the environment. A byproduct of the sewage treatment is semi-solid waste or slurry called sewage sludge. The sludge has to undergo further treatment before being suitable for disposal or application to land. For most cities, the sewage system will also carry a proportion of the industrial effluents to the sewage treatment plant, which has usually received pre-treatment at the factories themselves to reduce the pollutant load. If the sewer system is a combined sewer, then it will also carry urban runoff, storm water, to the sewage treatment plant. Sewage water can travel across treatment plants via piping and in a flow aided by the gravity and pumps. The first part of the filtration of sewage typically includes a bar screen to filter solids and large objects, which are then collected in dumpsters and disposal and landfills. Fat and grease are also removed before the primary treatment of the sewage. Now let's move on to a very interesting water conservation technique in which there are coordinated use of surface water and groundwater. It is known as conjugative use. We already discussed the conjugative use, a catchphrase for the coordinated use of surface water and groundwater, literally going with the flow to maximize sufficient yield. Conjugative use of groundwater and surface water in an irrigation setting is the process of using water from the two different sources for consumptive purposes. Conjugative use can refer to the practice at the farm level of sourcing water from both a well and from an irrigation delivery canal, or can refer to a strategic approach at the irrigation command level, where surface water and groundwater inputs are centrally managed as an input to irrigation systems. The planned conjugative use of groundwater and surface water has the potential to offer benefits in terms of economic and social outcomes through significantly increased water use efficiency. It supports greater food and fiber yield per unit of water use, an important consideration within the international policy arena, given the critical concerns for food security that prevail in many parts of the world. In fact, the resource level groundwater pumping for irrigation used in conjunction with surface water provides benefits that increase the water supply or mitigate undesirable fluctuations in the supply and control shallow water table levels and consequent solid salinity. A well-practiced technique we will discuss now is the aquifer storage and recovery. Aquifer storage and recovery is a direct injection of the surface water supplies such as potable water, reclaimed water, that is rainwater, or river water into an aquifer for later recovery and use. The injection and extraction is often done by means of a well. In areas where the rainwater cannot percolate the soil or where it is not capable of percolating it fast enough, that is the urban areas, and where the rainwater is thus diverted to the rivers, rainwater ASR could help to keep the rainwater within an area. ASR is used for municipal, industrial and agriculture purposes. The objective of AR is to replenish water in an aquifer. Injecting water into aquifer wells can prevent saltwater intrusion into freshwater aquifers and control land subsidence. In contrast, ASR wells are used to store water in the ground and recover the stored water for drinking water supplies, irrigation, industrial needs, or ecosystem restoration projects. The stored water may be recovered from the same well used for injection or from nearby injection or recovery wells. We would now talk about desalting water and extracting minerals using desalination techniques. Desalination techniques is a process that takes away the mineral components from saline water. More generally, desalination refers to the removal of the salts and minerals from a largest or a target substance, as in soil desalination, which is an issue for agriculture. Salt water is desalinated to produce water suitable for human consumption or irrigation. The byproduct of the desaltation process is the brine. Desaltation is used in many seagoing ships and submarines. Most of the modern interest in desalination is focused on the cost-effective provision of fresh water for human use. Along with recycled wastewater, it is one of the few rainfall-independent water resources. The process may be used for municipal, industrial, or any commercial uses. Water desalination process separates the dissolved salts and other minerals from the water. Feed water sources may include brackish, seawater, wells, surface water, which is rivers and streams, wastewater, industrial feed and process waters. Membrane separation requires driving forces including pressure, applied and vapor, electric potential, and concentration to overcome natural osmosis pressures and effectively force water through membrane processes. As such, the technology is energy intensive and research is continuously developing and evolving to improve the efficiency and reduce the energy consumption. It's about time we start discussing about the benefits of water conservation. So, water management can offer many benefits to state and the local government. Some of these benefits include reduced water and sewer cost. When we save water, we make more for the coming generations. Therefore, low flow water conservation devices reduce water usage and cost as well as its sewer cost. Weather-based irrigation controls. Decades ago, people were actually used to depend on the weather for agriculture and water. This is not the case as of now. But when we conserve water, it affects the agriculture sector too. This type of control system saves water usage and cost, especially during the hot summer months. Reduced energy usage. Energy deficit is an area of large concern and thus saving energy is the key to a lot of problems. Interestingly, low flow water devices reduce the amount of hot water used, which in turn reduces the amount of energy used to heat the water. Reduction of unbilled water. Many a times it is important to replace old inaccurate water meters, and bad distribution piping can result in increased revenues for the water district. When we do water conservation, we can actually reduce the incorrect water bills as well. Wastewater treatment, energy usage. Wastewater treatment plants are one of the largest users of energy within a city. Therefore, plant upgrades and aeration optimization can dramatically reduce energy usage and save money. Let's come to the conclusion. So, we know that Earth has only 1% of water which is drinkable, and therefore, water is the most precious resource of mankind. We truly need to understand and develop techniques to ensure that we save water not for today but for years to come. By following certain good practices, we can actually create a safe and secure tomorrow for our future generations with no dearth of clean water. And now it's time for a quick recap. In today's episode, we talked about the various aspects of water conservation. We learned the need, ways, and benefits of water conservation. We learned that saving water saves lives in more than one ways. This is all we have for you today. We hope you enjoyed the session. We shall be back with more on development. Until then, take care. Thank you and namaskar.